This is a spec for the first derivatives module. So derivatives 1. And the goal here is to really just let students realize that the derivative is nothing more than the instantaneous slope of a curve. So what we can do is we could say, find the slope of, and we'll give them some function here. Find the slope of y is equal to, and it could be any, you could give it some type of polynomial here. Maybe go up to third degree. And that'll keep it simple. I mean, we don't want to go with fancy functions right now, and that'll really give people the idea. But it could be, it could be 2x to the third minus x squared. So find the slope of that. And you could put simpler functions, 5x squared or something like that. Whatever, things that will be easy to also graph on this paper right here. And we'd also want to graph it. So let me just do a simpler example right now. But you can be a little bit. So let's say we have y is equal to 2x squared plus 3. Find the slope of y is equal to 2x squared plus 3 when x is equal to, we'll say when x is equal to 1. And right from the get-go, we should graph the equation. So let's see, 2x squared plus 3, it will look like that. It goes up super fast. It goes up like that, just like that. Now, the first time they click hint, just say, the slope is always changing. So this is kind of a real hint. The slope is always changing. So we can approximate the slope at x equals 1 by taking a point slightly away from 1, and finding the slope. We can then see what happens to the slope as that point gets nearer. So it's really telling the student how to do this type of problem. They click hint again. Say, let's find the slope. So the slope between x is equal to 1 and x is equal to 1.1 is, and then you say slope is equal to change of y over change in x is equal to change in y. We could write it down. So it's 2 times 1 squared plus 3 minus, or actually we should do the 1.1. We should do the larger one first. So, well, it doesn't matter. But 2 times 1.1 squared plus 3 minus 2 times 1 squared plus 3. All of that over 1.1 minus 1. And that'll be some number. I don't know. We should have a calculator here. It's going to be something slightly larger than, let's see, the slope here is actually going to be 4x. The slope here is going to be 4. So this is going to be, I don't know, it's going to be 4 point something, something, something. And then you could say, if they click hint again, the slope between, and actually for this first derivative module, we always want the slope to be an integer. It just keeps things clean, and it makes it easy to find the limits. The slope between x is equal to 1 and x is equal to 1.01 is, and then you're going to write this whole same thing over again. This time it's going to be 1.01, and it's going to be equal to, it's going to be something even closer, 4.0. It's going to be something. So we're going to see it's going to get closer and closer to 4. So you do this maybe, I don't know, 3 times. And then the last hint would be, so the slope at 1 is approaching 4. And this one actually could be a free answer if we want, especially if all of the answers are going to be nice, clean integer values. So we could actually make this into a free answer. Free answer module. And when someone clicks that last hint, we could actually draw that slope. We could, we're at the point x is equal to 1, and we want the slope to be 4. So the slope is going to look just like that at that point. So we really make it clear that that is the slope at that point. We'll just do this for a bunch of problems. This was a standard quadratic, a standard parabola. We could give him third degree polynomials that might look something like that. And you just pick a point that's, really a random point, someplace like that. Every now and then finding the zeros might be interesting, but that's not key. The key of this module is for students to go through that exercise of just calculating the slope between that point and a point slightly different from it. And we'll go in the positive direction because that's where the definition of the derivative tends to be. They normally say x plus delta x, not x minus delta x. So we should just keep doing that, and at least then they'll have the intuitive sense that all of a derivative is the slope at a point. And then we can kind of go into the derivative rules after that. And this is kind of a very gentle way. So any kind of quadratic, a third degree polynomial, I think is fair, but we could keep them reasonably simple. The main thing is that they go through this exercise.